projectile motion worksheet that we had for homework last night, we needed to do number 2 and 3 here. Number 2 says, a golfer is teeing off on a 170-meter long par 3 hole. The ball leaves with a velocity of 40 meters per second at an angle of 50 degrees with respect to the ground. That's the angle we're always given in these projectile motion questions, right? With respect to the ground. Or sometimes it says above the horizontal, but it means exactly the same thing. Assuming that she hits the ball in a direct path toward the flag, how far from the flagstick is the ball when it strikes the ground? This is a little bit of an issue. The words are a little bit of an issue with this question, the wording of it, right? We're told that the pin, or the tee, I should say, is 170 meters away from the hole, or away from the pin. That doesn't mean that's how far the ball goes. We hope that's how far the ball goes when we hit it, right? We hope it's perfect, right in the hole, hole in one. Okay, but the reality is most times that doesn't happen. How far does the ball go? Well, we don't know. We're going to have to find that. The question doesn't say how far does the ball go. It says how far from the flagstick or how far from the pin is the ball when it strikes the green. In other words, what we got to do here is find out how far the ball goes, and then we have to subtract that from 170 meters. Right, Dotis?
Yeah.
So let's treat this as a normal question, pretending we don't know this 170 meters. Don't let that throw you off. Just because you're given a distance doesn't mean you're going to plug that distance into an equation. You got that? I got an example of that for you, a perfect example. I call it the red car phenomenon. Hey, red car phenomenon. Listen carefully to this word problem. Okay? A red car is traveling down the road at 10 meters per second for 3 minutes. How far does the car travel? What are we given there? Time is 3 minutes. Velocity is 10 meters per second. Looking for displacement. Oh, we had one more given. The car is red. Right? That was given to us, right? That was data. Clearly, it doesn't matter to the question, right? If the color of the car doesn't matter, but yet it's still data, it's still given to us, then maybe that 170 meters doesn't really matter either. It does in the end, but not for the meat of the problem. All right, so here it is, 40 meters per second. It's a parabola, goes like this. It ends up down the way. Let's figure out how far that is. So how are we going to do that? Well, how are we going to do it? We know what to do every time. We break it into X and Y components every single time. Okay, as I was checking off your homework today and seeing who had it done, some people come up and said, I didn't know where to start for this question or for that question or whatever. Yes, you do. You know where to start for every single one of these questions. They are all exactly the same to start off. We draw a picture, and then we write down X and Y components. And for the X component, we say delta D over delta T. And for the Y component, we say VIT plus 1/2 AT squared. Okay, at this point, this is the third day you've been doing projectile motion. At this point, I will not accept an answer that says, I didn't know where to start. Okay, yes, you do. Okay, if you didn't write this down, you didn't try very hard. Okay, you didn't try hard enough. Okay, because we always start there. If you didn't remember this, okay, that's okay. I got a bad memory too. Go back and look in your notes because we start the same way every single time. Now, what do we know? What do we know? I got a funny angle. Shoot. Why am I saying shoot? Because I don't like them, right? I don't like funny angles. I got to get rid of funny angles. Let's take it off to the side. Let's get rid of that. Is it 40 degrees? 40 meters per second at 50 degrees. Let's get rid of that 40 meters per second at 50 degrees. This is the X component. This is the Y component. We're going to say cosine 50 degrees is equal to X over 40. X ends up being equal to, what is that? 40 times cosine 50. Thank you, Katie. 25.71 meters per second. And we're going to do the same thing almost for the Y component. Use sine. What's 40 sine 50? Katie, do you have that one? 30.64. Thank you. All right. Let's go back to the X and Y components now. The horizontal velocity. You know what? It starts getting a little bit tricky here. It's still the same idea every time, but every question looks slightly different at this point. Okay, up until now, they're all the same. What's the horizontal velocity here, can we? Nope. 25.71, right? We got rid of the 40. It's gone forever. We're going to replace the 40 for the x component with 25.71. We don't know what the displacement is. That's really what we want to find. We also don't know what the time is. For the y component, the displacement is going to be what? Anyway? No, the y displacement. Oh, yeah? 0, good, because it lands on the ground, right? The ball lands at the same height as it was launched at. Now, Kenway, you were answering the next question. You're getting ahead of us here. What's VI for the y component? Good, 30.64, not 40, that's gone. 30.64 is my y component. Times time plus 1/2 of negative 9.81 times time squared. Now, what do we do at this point? You guys remember? Notice? Yep. No, once the ball hits the ground, the displacement is 0 for sure if it started at the ground. Now, we would say that as the ball came down, you might be thinking of a velocity or something. The final velocity would not be 0. The velocity as it struck the ground would still be something, but its displacement is 0. If it starts at this height, goes back, goes up, comes back down, and ends at the same height it started, the change in vertical position is 0. Doesn't matter what path it takes, whether it's a parabola or straight up and down, whatever. What do we do at this point? Fernanda, do you remember what we did here to solve for t? Right, we divide everything by t. So that's just 0 divided by t is 0. That cancels, and we're left with what? 0 is equal to 30.64. Subtract 4.905 t. Take the 30.64 over by subtracting. And we solve for t here. What does that work out to be? Somewhere around 6 point something? 6.24? 6.25? See, what did you get? Okay, let's go with 3 digits, or 3 decimal places. That's better. Which we turn around and plug back into here. So delta D ends up being equal to 25 times 0.71 times 6.247 is, what do you get? 150 something? 160? 160.6 meters. Okay, that's not our final answer, but man, we're close. Now it's, what is this, like a grade 3 problem now? We got to say 170 minus 160.6, 9.4. So how far does the ball end up from the hole? 9.4 meters. Good? Comfortable? All right, we had the third question as well, which maybe was even a little bit tougher. It said, a punter in a football game kicks a high booming kick from his own goal line. He kicks the ball at 60 degrees with a velocity of 25 meters per second. What's the hang time? And then how far downfield does it land? Maybe not harder. Maybe not harder. We got to draw it out, right? Okay, let's draw a picture of it and see what it looks like here. He kicks the ball at 60 degrees, velocity of 25 meters per second, goes up like this, comes back down. What's the shape of that path called? It's a parabola, right? It's a parabola. We want to find the time, and we want to find out how far downfield it goes. You guys know where to start, right? X and Y every single time. Got a funny angle. Don't like the funny angle, so I got to get rid of it. Let's say cosine 60 degrees is equal to adjacent over 25. That's going to be 12.5. And we're going to say sine 60 degrees is equal to opposite over 25. 21.65 meters per second for the y component. All right, good. Let's go over here, do what we always do for every single problem. Every single projectile motion problem, including, listen carefully to what I'm about to say, including the first written response question on your final exam, which was remarkably like the question we're doing right now. We do this for every single one. Okay, everybody on your unit test when we do projectile motion questions, everyone on question number 1 on your final exam when we have a projectile motion question needs to start off this way. X and Y, if there's a funny angle, get rid of the funny angle. All right, what's the horizontal velocity? Let's go back to here, 12.5 meters per second. We don't know what the displacement is. We don't know what the time is. All right, fair enough. Vertical displacement here. Nolan, what's the vertical displacement? Starts on ground level, goes up, comes back down to ground level. Delta D for the y component is 0. Good. VI for the y component, we got to go back here. I don't remember what that is. Jessica, what's VI for the y component? Nope. VI, velocity initial for the y component. Sorry? 21.6? Yeah, that's right. Yeah. Just didn't hear you, that's all. 21.6 times the time, don't know what that is, plus 1/2 of neg 9.81 times the time squared, don't know what that is, but we can divide everything by time. That disappears, that disappears, that disappears. Half of 9.81 is 4.905. What is that? I would say 5.5-ish. 4.3? Okay. Give me the unrounded number, 4 point. Okay. 4 or 5 decimal places is good. Oh, we were looking for the time, right? So we can round that actually to, how many digits should it be? Should be 2 digits for the hang time, 4.4 seconds. But if we want to find out how far downfield it ends up, we use the unrounded number, plug it into there for time, and solve for the displacement. Cameron? Yes, we've hit the ground. Let's see. Let me just reread that question. The hang time. So question A says, what's the hang time of the punt? How long does it remain in the air? So in other words, if it remains in the air for 4.4 seconds, it hits the ground 4.4 seconds, or a 1,000th of a second after, right? So it's effectively the same time. Okay. How long is it in the air? How long does it take to hit the ground? Effectively the same time. All right. What do we got there? 12.5 times 4.4. That's going to give you somewhere in the range of, I don't know, 50 something. 55, I'm going to say. 55.2. We're actually going to round that to 2 digits, so it is going to be 55 meters. Right? How do we feel about those questions, guys? Listen, I'm not going to criticize anybody for having trouble with one of those questions. Okay, I'm not going to criticize anybody for getting one of those questions wrong or 2 of those questions wrong or all 3 of those questions. But, okay, don't sit there at your desk at home or your kitchen dining room table at home or on your desk here at school or whatever and say, I don't know where to start. Yes, you do. It can be the most complicated projectile motion problem in the world. One that conceivably I can't even solve. You know where to start. All of you know where to start. Okay? It's amazing if we actually take some time and don't give up so quickly. We give up too easy sometimes. And it's not just you guys. Okay, I'm not criticizing you guys more than anybody else in high school. We give up too easily. Okay, if we don't know how to do something within 8 seconds of looking at the question, I couldn't get it. That's our standard response sometimes, right? For some people, I couldn't get it. No, it means you didn't try hard enough if you couldn't get it in 8 seconds. Okay, if you work on this, if you're working on question number 3 for 15 minutes, all right, that's enough. Okay, that's fair enough if you can't get it at that point. Honestly, if the whole homework assignment is taking you more than 20, 25 minutes, can't get it at that point, all right, fair enough. You legitimately can't get it. But don't give up right away, please. All right. Let's try some practice problems for you to work on tonight, okay? Page 109 from your textbook, questions 1 and 2. Now, it is homework, yes. Question C, 2C, you're probably going to have a bit of a tough time with, okay? Don't give up on it right away. Let's see what you can do with it, okay? I promise you tomorrow we'll take a look at that. We'll make sure that you're okay with it before you guys write a unit test. But I'd like to see what you can do with that, with question number C there, before I show you, all right? If you can't get this, if you can't finish these 2 questions within about 20 minutes, okay, you're having some trouble and you can probably stop. Okay, but if you're looking at it for 16 seconds and you're saying, I can't do it, I don't know how to do it, okay, it means you're giving up too quickly. Don't work for an hour at it, but don't work for 10 seconds at it either.